Students, good morning. Today I am going to discuss about the definition, principles and application of liquefaction process. Definition, principles and application of liquefaction process. Liquefaction process is a process of converting a gaseous substance into a liquid state. Liquefaction is a process of converting a gaseous substance into a liquid state. This change of state is achieved by manipulating the temperature and pressure of the gaseous substance. Manipulating its temperature and pressure. Manipulating temperature and pressure means either by decreasing temperature or by increasing pressure or by means of both. In all the three cases, they tends to force the molecules of the gas or gaseous molecules to closer to each other. In all the three cases, what happens is, in all the three cases, they tends to force the molecules of the gaseous substance to bring to close to each other. Clear? This leads to clumping of molecules. It resulted liquid formation. So what is meant by liquefaction process? Liquefaction process is a process of converting a gaseous substance into a liquid state. The change of state is achieved by manipulating the temperature and pressure. Manipulating temperature and pressure means decreasing temperature, either by decreasing temperature or by increasing pressure or by means of both. This results, they tends to force the gaseous molecules to closer to each other. This results clumping of molecules and the liquid formation resulted. Clear? Right. Let us see one by one. What is meant by decreasing temperature? While you decrease the temperature of gaseous molecules or while you increase the pressure of gaseous molecules, what will happen? Decreasing temperature or increasing pressure. In both cases, they slow down they reduce the kinetic energy of gaseous molecules. Kinetic energy of gaseous molecules gets reduced. Decreasing the temperature or by increasing the pressure, in both cases, the kinetic energy of molecules of the gaseous substance gets reduced. The reduction in kinetic energy, which in turn slow down the movement of molecules. The slowdown process allows the intermolecular forces of attraction. Intermolecular forces of attraction This slowdown process allows intermolecular forces of attraction to overcome the to overcome the intermolecular forces of repulsion. Clear? You are going to decrease the temperature or you are going to increase the pressure. In both cases, what will happen? First step, the kinetic energy of molecules gets reduced. The reduction in kinetic energy of the molecules causes to slow down the movement of gaseous molecules. The slow movement of gaseous molecules, which in turn results or allows the intermolecular forces of attraction to overcome the intermolecular forces of repulsion. This action leads to clumping of molecules and liquid formation is resulted. This is the principle behind the liquefaction process. Clear? Right. What next? Application of liquefaction process. Application of liquefaction process. One is the task of storage, handling and transportation. The task of storage, handling and transportation of gases is achieved. Storage plays a vital role. In our home appliance, we got one LPG cylinder whose weight is 14 kg. The real-time volume of this 14 kg LPG gas is liquefied petroleum gas LPG is 600 times greater than that of what you get the one cylinder. In real-time process, you need a tanker lorry for purchase of 14 kg of one cylinder. 600 times the volume gets decreased by means of liquefaction process. Next, handling, somewhat difficult, and transportation. So the task of storage, handling and transportation of gases is achieved by liquefaction process. Hence, what I am trying to say is liquefaction process has gained wide acceptability, in recent years because of the task of storage, handling, transportation of gases. Clear? 600 times the volume gets decreased through liquefaction process. Apart from that, separation of a gaseous mixture into its component parts. Separation of gaseous mixture into its component parts by means of liquefaction process is achieved. Say for example, liquid oxygen and liquid nitrogen can be achieved or produced from air by liquefaction process. This is the simple line diagram. Production of liquid oxygen LOX and liquid nitrogen LIN from air by liquefaction process. A simple process. Air is fed into a filter press in order to remove water vapor, dust, impurities, inerts. Number one is a filter press. It is used to remove the water vapor, dust, impurities, inerts. Then next one is carbon dioxide. If any carbon dioxide or hydrocarbons are present, it should be removed from the air because it forms a paster or it stuck the process. Clear? Carbon dioxide and hydrocarbon, if anything is present in the air, it is removed in the second stage. Carbon dioxide, hydrogen remover. Then fresh air fed into a reunion valve. From reunion valve, the air fed into a compressor. In compressor, the air gets compressed to about 200 atmospheric pressure. Such a huge pressure increase. Due to increase in pressure, or the pressure is increased by decreasing the volume of air. Decrease in volume causes to increase the temperature of air. Hence, the compressed air is fed into a high pressure tube. Number 5 is the heat exchanger. Regenerative heat exchanger, double pipe heat exchanger. This is high pressure tube, this is low pressure tube. The compressed air is fed into a heat exchanger where the temperature of air is reduced to its room temperature. From heat exchanger, the compressed air is fed into a expansion valve. In expansion valve, the first section is convergent. The first section is convergent. The air experiences still increase in pressure. Once it enter into the throttle area, all of a sudden the air gets expanded. The sudden expansion causes to decrease the temperature of air to its critical temperature, near about critical temperature or below the critical temperature. This is the expansion area. All of a sudden the air gets expanded. Due to expansion, there is a formation of liquid. Expansion causes to decrease the temperature to a great extent. Hence, this air gets liquefied. Hereafter, this is a two-phase region. One is liquefied air, another one is unliquefied air. This is unliquefied air. This is liquefied air. Unliquefied air with low temperature again fed back to the low pressure tube side in a heat exchanger. Here, the temperature of compressed air gets further cooling. This is called as pre-cooling. After pre-cooling process is over, the low temperature air is reunited with the fresh air and the mixer makeup air is again fed into the compressor. Compression, cooling, expansion. Compression, cooling, expansion. Repeated process causes to produce the liquid nitrogen and the liquid oxygen. Right. This is the flash drum used to separate the unliquefied air and the liquefied air. Unliquefied air is again fed back to the low pressure tube side. Liquefied air is sent to a fractional distillation column. In fractional distillation column, the temperature is maintained suitably. That means liquid nitrogen has a temperature of minus 196 degrees Celsius. Liquid oxygen has a temperature of minus 183 degrees Celsius. Due to difference in temperature, this temperature difference causes to separate by using a fractional distillation column. This is a simple process. So what I am trying to say is, apart from the task of storage, handling and transportation of gases, the liquefaction process has gained wide acceptability in recent years because separation of gaseous mixture into its component parts is achieved by means of liquefaction process. Separation of gaseous mixture into its component parts is achieved by liquefaction process. This is a simple example. Separation of oxygen and nitrogen from air by liquefaction process. Okay. Production of liquid oxygen. Production of liquid oxygen. Production of liquid nitrogen. Both are highly useful in missile and rocket development. LOP, rocket development. First point, production of liquid oxygen and liquid nitrogen widely useful in rocket and missile development, as well as low temperature refrigeration. Okay, what next? Production of liquid helium. The liquid helium is widely useful in space research. Liquid helium is widely applicable in space research. Clear? Production of liquid hydrogen. This is missile as well as nuclear weapons and rocket propulsion. Liquid hydrogen is widely used in nuclear weapons as well as rocket propulsions. Clear? So liquefaction process is much more important. This knowledge should be very much essential for chemical engineers like you. Clear? Thank you.